Hello, our most valued student. My name is Confident, and welcome to this third, fourth, or fifth lesson where we're looking at the gradient of a line, and this is for grade 10. And we're looking at the analytical geometry, and I've already done in the previous lesson. As you remember, you guys were following, we were looking at the midpoint. All right, and we did a few calculations when we're looking at the midpoint of a line. I will encourage you grab hold of the previous video. Now we're looking at the gradient of a line. Now what is the formula for the gradient of a line? The abbreviation or gradient is represented by a small letter m, while midpoint is capital letter. This is for midpoint, right? But for gradient you use a small letter m that will represent gradient. So don't confuse them when you're writing. Be very sensitive. So if I say midpoint of line AB, not midpoint, gradient of line AB in this case is equal to YB minus YA over XB minus XA. That's how you find, that's the formula for the gradient. Sometimes they usually say, what is gradient? It's increase in Y. That's what it means, YB minus YA over increase in X, which is represented by XB over XA. Are you with me? So let's make an example here. It says already, the question goes so fast. It says given the points A, B, C and D, show that AB, that sign means is parallel. That's what it means. Show that AB is what? Is parallel. Is parallel to CD. What are parallel lines? Parallel lines are like this. If I draw a line like this and I draw another line like this, so to show that the lines are parallel, you indicate by this. So they want us to show that, for example, AB is parallel to CD. So what are we going to use? The gradient. So first of all, we are going to come here and say this is my XA, my YA, my XB, my YB. This is very important. My XC, my YC, my XD, my YD. So that when you're using the formula, it's easier. So gradient M of AB is equal to, remember the formula, YB minus YA, you separate, over XB, you need to know this, minus XA, which is equal to, now YB, you see it's 3 there, it's 3 minus from the formula, but YA is 5 over XB is minus 2. Then minus from the formula, but look at XA, it's negative. So negative, negative 1. Be careful of such. Are you with me? Then equal to, it will give us the answer. What is the gradient of what? Of AB. Just like that. It's 3 minus 5 over negative 2 minus minus 1. Just do that. I get the answer of 2. So the gradient of AB is 2. Now let's look for the gradient of CD. We continue now. CD is YD minus YC over XD minus XC, which is equal to, now what is my YD? It's 2 minus YC, it's 10 over XD is 5 minus X is 9, right? Which is equal to, we do the same thing, we calculate the gradient as is. So it's 2 minus 10 over 5 minus 9 equal to, I get the same answer, 2. Now look at this. The question is, you are given this point, then show that AB is parallel to CD. Guess what now? What happens is, you are going to say gradient of AB is equal to the gradient of CD. which is equal to what? Which is equal to 2. Therefore, AB is parallel to CD. What concept are we bringing here? We are saying parallel lines have same gradient. So always remember that concept. Parallel lines have got what? The same gradient. Meaning, if I come here and say I've got a line like this, and then I've got another line like this, and then I put this arrow to you and say this arrow, and I put this arrow. So if this is line A, B, and this is line D and F, what that arrow means, it means these lines are parallel. But now what you also must know is that gradient of AB must also be equal to the gradient of DF. So parallel lines have the same gradient. Alright, so that is the first part that you need to know. Okay guys, so let's move on now and look at a few questions that they can play around using the gradient. Show that the points A, B, and C are collinear. There is another concept. Collinear. If the coordinates of the points are, they give us the coordinates. Now, what does collinear means? Collinear means, if I can come here and just introduce collinear. Collinear means if I've got a point here, A and B. Now, if a point is collinear, it must lie on top of the other one. So if this is C and this is D, so A, B, C, D are collinear. So A, B, C, and D are collinear, meaning they lie on the same straight line. Are you with me? Collinear means lie on the same straight line. But there is something interesting about collinear points. I want to show you this. If I've got these points, I'm going to do them in different lines. If I had that, and I had another point that on the same line, and I had another point that, all coming from the same line, and then I say to you, this is A, this is B, this is C, this is D, and then I say to you A, B, C is a straight line. A, B, C, D is a what? A straight line. Now, to show you the concept of collinear, look at this. I can take this point, this point here, and move it like this, you see? And I can take this point, okay, and move it like this. Right? So the D will go here. I know it will just get mixed up there. Some of it needed to repeat and everything, you know. It's not gonna be as I wanted. This was A, blah blah blah. But anyway, look at this. I can write here now and say this is my A, B, this is my BC, this is my CD. But look, I can now put these arrows. See? They were in a straight line, but also there is the concept of that straight lines are also parallel, meaning this is parallel to that, and that is parallel to that. So when you are using collinear, you must remember gradient. Collinear equals same gradient. Are you with me? So which means M of AC in here, gradient, meaning remember small m I told you is gradient. Gradient of AC is equal to gradient of CD, which is equal to gradient of DB. That's what it means. It can be which is equal to gradient of AB. Anything which is equal to gradient of AD, which is equal to gradient, you can choose any line, of CB. Anything as long these points are on the same straight line. So this question, what is saying? It says show that the points A, B, C are collinear if the coordinates of the points are A, B, and C. So here it's up to you. You can use that part to say this is XA, XB, YB, sorry about that. That's common error sometimes that happens. You call it XX, XAYA, not YB, and then here XB, YB, and XCYC. So if they are collinear, it's up to you how you want to do it. You can say, okay, I'm gonna say the gradient of AB, right? And then find the gradient of AC. Alright, so once you connect them, there's AB, there's AC, or you can say the gradient of BC. If you are getting the same answer, if they are equal, it means they are collinear. Let's start with the first one. Remember the formula, what does it say? Let me write it on top. M is equal to Y. For example, it's Y2. Some they use that word, Y2 minus Y1 over X2 minus X1. But the 2 can be your A and your B. So here, the gradient M is equal, M of AB is equal to what? YB or YA, that doesn't matter. YB minus YA over XB. You must maintain it now. XB minus XA. Once you start with B, you maintain it. So gradient of AB is equal to what? What is YB? Which is 1 minus YA minus 2. See that? Be careful there. Over XB, 1 minus XA, 2. It will give us the answer here, right? Let's do the other one. M of AC is equal to YC minus YA over XC minus XA. As I said, anything you could find AC. Okay, this is AC actually. So YC it's 7 minus YA, which is minus 2, see, over XC is minus 1 over XA minus 2. We'll use the calculator once. Let's look at the last one. M of BC is equal to YB minus YC over XB. I must maintain. Don't say XC now. Remember I told you that don't interchange. When you start with B, follow up with XB minus XC. So what do we have? YB is 1 minus YC is 7 over XB is 1 minus XC, guys. What is XC? Minus 1. Alright, so equal to. Now let's look at the answers of all this. I'm just gonna use the calculator once here just to see what I'm talking about. Start with the first one. 1 minus 2 over 1 minus 2. The answer is negative 3. That's the first one. Let's come here. Remember it's negative 3. 7 minus 2 over minus 1 minus 2. The answer is negative 3. Don't forget it's negative 3. There again. 1 minus 7 over 1 minus 1, which equals to, did I miss? It's not supposed, yeah, like it's supposed to be 2. Negative 3. You see? So what am I getting here? Here I'm getting a negative 3 and negative 3 and negative 3. So it's sure that the points A, B, C are collinear. Then you can say that statement, this statement is actually what it means. This is your conclusion, to say M of AB is equal to M of AC, which is equal to M of BC. Therefore, you have counted. You see, there is A, there is B, there is C. Therefore, A, B, C are collinear. So, collinear, use gradient. If they ask you about collinear, use gradient. It's the same as parallel lines. So, the concept of collinear and parallel lines, you just have to use the same word. So, even here, that collinear and parallel, they are together. You use the concept of the gradient. Alright, so look at this now. This is our last part now to end up the series on the analytical geometry. Given the points A, B, C, and D, show that AB now is perpendicular to CD. How do you write that? You write it like this: AB is perpendicular to CD. Now let's look at this perpendicular concept. If I draw a line like this and I draw another line like this, now I will call this A. Okay, let's call this actually AB, and then we call this CD. If these lines, if AB is perpendicular to CD, what it means is they meet at 90 degrees there. That's what perpendicular means. But there is a special concept. When you're talking about perpendicular lines, you are going to use gradient. Okay, so I'm going to come back to this thing of the gradient, but let's come back here. You'll see what I mean. You do the same thing here. You have got your XA, your YA, your XB, your YB, your XC, your YC, your XD, your YD. Just do that, it helps you a lot. So now we are going to find gradient M of AB. You know the formula? YA minus YB. You can use any. Let me use this one now. But usually, let's maintain consistency. YB minus YA. It's still the same thing, guys. YB minus YA, but you maintain at the bottom also XB minus XA. Are you with me? Now, YB is minus 7 minus YA, which is minus 3. Those are the tricky areas, they always confuse you. XB is 6 minus XA is 3. Then we're gonna get an answer here. Let's see what it gives us. So it's negative 7 minus 3 over 6 minus 3. Alright, which is negative 4 over 3. Okay, that's the gradient of what? AB. Let's find the gradient M of CD, which is what? YD minus YC over XD minus XC. Let's continue. YD is what? 3 minus YC, which is 0 over XD, which is minus 1 minus XC, which is minus 5. You see that? Equal to, you just have to be sensitive to these negative things, but right as you see it, guys. 3 minus 0 over negative 1 minus 5. There I get 4 over 3. I mean 3 over 4. Just check it again, it was 3 over 4. Now look at this. To show that AB is perpendicular to CD, this is how you conclude. If I say, let's take this, if I say gradient of, I want to use something different. If I take gradient of AB, I multiply it with the gradient of CD. Look what is going to happen. What is gradient of AB? It is called minus 4 over 3 times CD is 3 over 4. If you multiply that, you see what we're getting? Negative 4 over 3. I think you can even multiply without this, times 3 over 4. What is the answer? It's minus 1, because you cancel that, cancel, you get minus 1. So we come here now, here, when we talk about use gradient, and then you must know M of AB times M of CD is equal to minus 1 for perpendicular lines. Perpendicular lines. So this is a proof. If you want to prove that the lines are perpendicular, you find the gradient of AB, you find the gradient of CD, you multiply them. When you get minus 1, it's a sign those two lines are perpendicular. So look at this. We found the gradient of AB, we found the gradient of CD, we multiplied it, we got minus 1. The question was, given the points these, show that AB is perpendicular to CD. And then you're going to say, therefore, AB is perpendicular to CD. The fact that you got minus 1, we understand how this works. In some books, they will just use this formula to say gradient of line 1 times gradient of line 2. Let's say this was line 1 and this is line 2. So gradient of line 1 times gradient of line 2, if they are perpendicular, I must get minus 1. But if I say gradient of line 1 is equal to gradient of line 2, then here it means these lines are parallel, remember, or collinear. Those two key things are very important. For same gradient, if the gradients are equal, they are parallel or collinear. If the gradient gives you a negative 1 when you multiply the line 1 and line 2, it means they are perpendicular lines. So guys, I'm wrapping up this, and next time you see me, I'll be doing previous papers just to prepare you for the final exams. We've come to the end of our lesson. Now the last part, what am I asking you to do? If you're not subscribed, it's a crime for you to be learning and learning on this channel. You always keep coming back and coming back, and you know it's helping you a lot, but you choose not to subscribe. In other words, you are telling me, look, I don't want to acknowledge that this channel is helping me. If you want to acknowledge that, guys, just turn on that subscription button. Just press the subscription button. It doesn't pay you anything. What does it do to you though? Remember, I'll be with you from grade 10, grade 11, grade 12. This is going to build your maths. Trust me, you're guaranteed for a distinction if you follow this. But it's for the underdogs. And underdogs, someone says, I'm struggling, but I tell you, you are my distinction learner. In grade 12, we will smile together. Because why? You're following up each and every video that I'm posting. But you can't follow up if you're not subscribed, you see? See you again, guys, in the next time. Remember to share it, to like it if you like it, and leave me a comment. Thank you.